Do you know about effervescent granules? Effervescent granules are coarse to fine granules that contain acid and base components, which are going to react in presence of water, thereby releasing the carbon dioxide gas. This produces effervescence and results in palatable and quick acting solution. Hello everyone, welcome back to my channel Pharma Talk with Imran. In today's video, I am going to present a new topic called as effervescent granules. What are effervescent granules? Effervescent granules are coarse to fine granules, means they may be vary from coarse size to fine size, and they are containing one acid and a base component, which are going to react in presence of water and then release the carbon dioxide gas. This produces a effervescence and results in palatable and quick acting solution. Means effervescent granules are they are from coarse to fine size in their particle size, and they contain one acid and a base component, and they come when they are coming in contact with the water, they are going to release the carbon dioxide gas. So in a simple definition, effervescent granules release carbon dioxide when they are going to dissolve in water due to an acid base reaction. So here the reaction which is going to take place is acid base reaction. So in the simple definition, we can say these granules release carbon dioxide when they come in contact with the water. Why we use effervescent granules? Or you can say, what are the advantages of using or formulating effervescent granules? It is very useful in case of to mask a unpleasant taste of the drugs. If the drug having unpleasant taste, then we can easily mask the bad taste. Then we can get the quicker onset of action because the drug is already in the solution. Then it is helpful in increasing the or improving the patient compliance or acceptance. Then here the uniform dosing is possible. Then it is very easy to swallow. Then there is an enhanced stability as compared to the solutions. Disadvantages of effervescent granules. The main disadvantage is it requires moisture proof packing. Why? Means it is hygroscopic in nature, means that is going to absorb the moisture easily and become wet. Then the another disadvantage is it is quite costlier for manufacturing and then bulky to transport. Now, what are the basic ingredients which are going to require here? So there are mainly three essential components which are required in preparation of effervescent granules. The first one is acidic component. So we require one minimum acid or acidic component like citric acid, tartaric acid, malic acid, and then we require alkaline compound, that is basic compound like sodium bicarbonate and potassium bicarbonate. Component is the medicament, or you can say the drug, and the fourth component, which is optional, means it is added to improve the formulation, like we can add the flavoring agents like orange, then lemon, and we can add coloring agent, we can add sweetening agent. Okay, and here is the flow chart. Here is the flow chart which is going to describe how the process of manufacturing or formulating the effervescent granules. There is a step-by-step process. First one, we require acid source, that is citric or tartaric acid. Then second one, we require base source, that is sodium bicarbonate. Then third thing, we require medicament, that is drug or API. Then we require additives. Then finally we will get the effervescent granules. Here the step-by-step method of preparations are there. So there are three common methods which are used in the manufacturing of effervescent granules. The first one is dry method or heat method. Here we use citric acid crystals which are going to melt on heating. In the first step, we are going to mix the drug with sodium bicarbonate and then with acids. Then we are going to apply the heat 93 to 100 degrees centigrade, due to which the citric acid is going to melt and binds the powder. Then we are going to pass through this mixture through a sieve to get the granules. Then finally we are going to pack these dried granules in airtight containers. Then another method is there, that is a wet method or non-heat method. Here there is no heat required. There are basic steps like mixing all the dry powders. So in the first step we are going to mix all the dry powders, then add alcohol, then add water, then they are added in a drop wise manner to form a damp mass or wet mass. Then we are going to form a granules, that is granulation technique. By sieving we are passing this damp mass in a sieve, like it looks like this one. Then we are going to dry at 50 approximately 50 degrees centigrade. Then finally the third method, that is fusion method. So here the citric acid monohydrate releases water of crystallization, which is going to bind with the granules. Means here the acid is going to release a water of crystallization which is going to bind with the granules. What are the basic steps here? We are going to mix the ingredients, then gently heat to release the bound water present in the mixture. Then the mass becomes very sticky in nature. Then we are going for granulation technique, that is we are passing through the sieve. Then apply subject the mixture for drying. Then finally pack the final product. Here the reactions, that is acid is going to react with the sodium bicarbonate, that is acid base reaction is going to take place. The resultant product is of course the salt and water. Example, citric acid, that is CH3COOH. It is going to react with sodium bicarbonate and it form sodium citrate with the release of carbon dioxide gas and water. So what are the packaging requirements here? Because these granules are moisture sensitive, we use airtight packing like aluminum foil sachets, then glass containers having airtight caps, then laminated moisture resistant pouches. Then storage, of course, store in a cool place, cool, dry and airtight containers. So there are the basic examples for effervescent granules, that is marketed products. We can see ENO, which is used as antacid. Then Disprin, it is used as analgesic. Then vitamin C tablets, it is a full supplement for vitamin C. Then ORS,